Hello and welcome. Chapter 21b on applications of volume and surface area of room, box and closed box. This video includes the timestamp. From the description box, you can directly go to the specific part of the video or the specific question number of the chapter. Question number 2. The dimensions of a classroom are L equal to 15 meter, B 12 meter, H 7.5 meter. Find how many children can be accommodated in this classroom, assuming 3.6 meter cube of air is needed for each child. So the dimensions of the classroom are L, B and H, length, breadth and height. So if you study this question, each child needs 3.6 meter cube of air out of the total volume of the classroom. So first we have to find out the total volume of the classroom, and that is equal to LBH, and this is equal to 15 multiplied by 12 multiplied by height 7.5 meter, that is meter cube. So this is the volume of the room. And this is also the volume of the air inside the room. Volume of air required for one child is equal to 3.6 meter cube. The total volume of the air inside the classroom will be shared by all the children. Therefore, number of children that can be accommodated is equal to LBH divided by 3.6. This is also meter cube and this is meter cube, and that is equal to 15 multiplied by 12 multiplied by 7.5 divided by 3.6 meter cube divided by meter cube. This will get cancelled, and 12 threes are 36 and 3 5s are 15 and 3 0.1, and that is equal to 375. So this room can accommodate 375 children with sufficient oxygen or sufficient air. Question number 3. The length, breadth and height of a room are 6 meter, 5.4 meter and 4 meter respectively. Find the area of its 4 walls and its roof. So this room has 4 walls, and out of that, this wall is equal to this wall. Area of this wall is equal to this wall, and area of the right side wall is equal to area of the left side wall. So this is L, B and H. Area of this side wall is equal to BH, and area of the front and back wall is equal to L into H. So we can write area of front and back wall is equal to 2 times L into H, and this is equal to 2 times L is equal to 6 meter and H is equal to 4 meter. This is 48 meter square. And also area of the side walls, the left and right side walls, is equal to 2 times, this time it is B multiplied by H, and that is equal to 2 multiplied by B is 5.4 meter and H is equal to 4 meter. And this is equal to 43.2 meter square. Therefore, total area of the walls is equal to 48 meter square plus 43.2 meter square, and this is equal to 91.2 meter square. So this is question number 1, answer for question number 1. Now question number 2, the area of the roof. The area of the roof means this surface. Therefore, area of the roof is equal to, then in this case it will be L into B. So this is equal to 6 meter multiplied by 5.4 meter, 32.4 meter square. Question number 4. A room 5 meter long, 4.5 meter wide and 3.6 meter high has one door that is 1.5 meter by 2.4 meter and two windows, each 1 meter by 0.75 meter. Find the area of the walls excluding doors and windows. Number 2. The cost of distempering the walls at the rate of ₹9 per meter square. So in this case, this is L is equal to 5 meter, B is equal to 4.5 meter and height is equal to 3.6 meter. So area of the walls without doors and windows is equal to 2 times LH plus BH. So this one and this one and this one and this one, and that is equal to 2 times L is 5 into H is 3.6 plus B is 4.5 multiplied by 3.6, and this is meter square. So if we take 3.6 common, then this is 5 plus 4.5 meter square. This is 2 into 3.6 multiplied by 9.5 meter square. This is equal to 70.56 meter square. Now we have to deduct the area of the door and area of the windows. Area of door is equal to, the door dimensions of the door is 1.5 meter by 2.4 meter. So this is 1.5 meter multiplied by 2.4 meter, and this is equal to 3.6 meters square. Now there are two windows and each is 1 meter by 0.7 meter. So area of windows is equal to 2 times, and one window is 1 meter multiplied by 0.75 meter, and this is equal to 1.5 meters square. So number 1, area of the walls excluding doors and window, that is equal to area, required area is equal to 70.56 minus area of the door, that is 3.6 minus area of the windows 1.5 meters square, and this is equal to 66.96 meters square. This is number 1. And number 2 is the cost of distempering the walls at the rate of 9 per meter square. So cost is equal to, so 1 meter cost ₹9. For 66.96 meter square, we have to do the distempering for 66.96 meter square. So 66.96, this is equal to ₹602.64. Question number 5. The dining hall of a hotel is 75 meter long, 60 meter broad and 16 meter high. It has 5 doors of dimensions 4 meter by 3 meter each and 4 windows of dimensions 3 meter by 1.6 meter each. Find the cost of papering its walls at the rate of ₹12 per meter square and the cost of carpeting the floor at the rate of ₹25 per meter square. So the dimensions of the room is L, B and H, and here this wall has the dimension of L into H as well as this wall, and this wall has the dimensions of breadth multiplied by height and also for this wall. Now first we will find out the surface area of the 4 walls. is equal to 2 multiplied by LH, these two walls, plus 2 multiplied by BH, and that is equal to 2 multiplied by L is 75, H is equal to 16, plus 2 multiplied by B is 60 meter and H is 16 meter. So this is meter square surface area. And if you take 2 multiplied by 16 common, then 75 minus 60, plus 60 meter square, and this is equal to 4320 meter square. Now from this surface area, we have to deduct the area of the 5 doors and 4 windows. So area of 5 doors is equal to 5 multiplied by 4 meter multiplied by 3 meter, and this is 60 meter square. And again, area of 4 windows is equal to 4 multiplied by 1 window is 3 meter multiplied by 1.6 meter is equal to 19.2 meter square. So we have to deduct this area of the doors and the windows from the surface area of the 4 walls, and from that we'll get the area for the papering. So wallpaper area is equal to 4320 minus 60 minus 19 is equal to 4240.8 meters square. This is the area of the wallpaper required. Now the cost of papering. Cost of papering is equal to rupees 12 multiplied by the total surface area. 50,889.60. So this is number 1. Number 2, cost of carpeting the floor. So we have to first find out the floor area. Floor area is equal to L multiplied by B. So this is 75 meter multiplied by 60 meter is equal to 4500 meter square. So the cost of carpeting is equal to, per meter cost is rupees 25 multiplied by 4500 meter square. So that is equal to rupees 1,02,500. The total cost of carpeting the floor at the rate of rupees 25 per meter square. Question number 6. Find the volume of wood required to make a closed box of external dimensions 80 cm, 75 cm and 60 cm. The thickness of the walls of the box being 2 cm throughout. Suppose this is the box and all the dimensions, external dimensions are say LE, BE and HE, and this is the internal length of the box, say Li, and this is 2 cm less in the left side and 2 cm left in the right side, and same is the case with the internal breadth of the box, and this is also 2 cm less and 2 cm less on both sides, and similarly it is total of 4 cm less than the external dimensions. So first let us consider the external dimensions. So what are the external dimensions? LE length, external length is equal to 80 cm, and BE external breadth equal to 75 cm, and external height is equal to 60 cm. So external volume VE is equal to 80 multiplied by 75 multiplied by 60 centimeter cube, and this is equal to 3,60,000 centimeters square. This is the external volume of the box. Now we'll consider the internal volume, and for that we have to consider the internal dimensions. Li internal length is equal to 80 minus 4 and this is equal to 76 centimeter, and internal breadth equal to 75 minus 4 is equal to 71 centimeter. Internal height is also equal to minus 4 and this is equal to 56 centimeter. So internal volume Vi is equal to 76 multiplied by 71 multiplied by 56 centimeter cube, 3,02,176. Now we have to find the volume of the wood required to make the closed box. So in this case, the external volume minus internal volume is the volume of the wood required. So volume of wood required is equal to V external, external volume minus V internal, 57,824 centimeter cube of wood is required to make this closed box. Question number 7. A closed box measures 66 centimeter, 36 centimeter and 20 centimeter from outside. If its walls are made of metal sheet 0.5 centimeter thick, find the capacity of the box. Number 2, volume of the metal sheet, and weight of box if 1 centimeter cube of metal weighs 3.6 gram. So this is actually same. This is LE, BE and HE, length, breadth and height. So it is given external length LE is equal to 66 centimeter and external breadth BE is equal to 36 centimeter and external height HE is equal to 21 centimeter. So external volume VE is equal to 66 multiplied by 36, 36 multiplied by 21 centimeter cube. This is the external volume. Now here the thickness is 0.5 centimeter on all the sides. So total of 1 centimeter have to be deducted for the dimensions. So Li internal length is equal to 66 minus 1 is equal to 65 centimeter. Internal breadth Bi is equal to 36 minus 1 is equal to 35 centimeter and internal height Hi is equal to 21 minus 1 and this is 20 centimeter. Now internal volume Vi is equal to 65 multiplied by 35 multiplied by 20 centimeter cube, and this is equal to the capacity of the box. This is the capacity of the box and this is number 1. The capacity of the box is the internal volume of the box. Next we have to find the volume of the metal sheet. This is the closed box. So number 2, volume of metal sheet is equal to the external volume minus the internal volume. Question number 8. The internal length, breadth and height of a closed box are 1 meter, 80 centimeter and 25 centimeter respectively. If its sides are made of 2.5 centimeter thick wood, find the capacity of the box, and number 2, volume of the wood used to make this box. So this is also a closed box, and in this case all these internal dimensions Li, Bi and Hi are given. So this side will consider the internal dimensions. Li is equal to 1 meter, this is equal to 100 centimeter, and breadth, internal breadth is equal to 80 centimeter, and internal height is equal to 25 centimeter. So volume VI, that means the internal volume, is equal to 100 multiplied by 80 multiplied by 25 centimeter cube, and this is equal to 2 lakh centimeter cube. And this is actually number 1, and this is the capacity of the box. Now for number 2, we have to consider the thickness of the wood, and here the thickness we have to add with the internal dimensions. Here we will consider the external dimensions. So length LE is equal to, the thickness is 2.5 centimeter. So LE is equal to 100 plus 2.5 plus 2.5 on both sides, and this is equal to 105 centimeter. And breadth, external breadth BE is equal to, it is 80 plus 5 on both the sides is equal to 85 centimeter. External height is equal to 25 plus 5, 2.5 centimeter on both ends, and this is equal to 30 centimeter. So we'll consider the external volume VE is equal to 105 multiplied by 85 multiplied by 30 centimeter cube. This is equal to 2,67,750 centimeter cube. Now what is the volume of the wood required? That is equal to, volume of the wood required is equal to external volume minus internal volume. So wood volume is equal to V external, external volume of the box, minus V internal, the internal volume of the box, and this is equal to 67,750 centimeter cube of wood is required to make this box. Question number 9. Find the area of metal sheet required to make an open tank of length 10 meter, breadth 7.5 meter and depth 3.8 meter. This is an open tank. Suppose the dimensions are L, B and H, length, breadth and height. So here we have to find out the metal sheet required. So we need to find out the surface area of this box without the top surface. So there are 5 surfaces, the bottom surface, there are 2 front surface and the back surface, and the left side and right side surfaces. And this is the front surface, and here the surface area is L into B, and there are similar surface and which is the back surface, and the right side surface is this one, and here the area, surface area is B into H, and there is similar surface at the left side, and the top surface is not there because this is an open tank, but the dimension of the top surface is same as that of the bottom surface, and this is the dimension of the bottom surface as well as top surface, and here the surface area is L into B. Sorry, this is not L into B, this is L into H. So it is given L is equal to 10 meter, breadth is equal to 7.5 meter and height is equal to 3.8 meter. So total surface area of the metal sheet is equal to the front and the back surfaces. So there are 2 surfaces, twice L into H plus left side and right side surfaces 2 times P into H, and the bottom surface, that is L into B, because it is an open tank and there is no top surface, and this is equal to 2 multiplied by 10 into H is 3.8 plus 2 times B is 7.5 multiplied by H is 3.8 plus LB, that is 10 multiplied by B is 7.5. So this is a meter square surface area, and this is equal to 208 meter square. The metal sheet required to make the open tank is 208 meter square. Question number 10. A tank 30 meter long, 24 meter wide and 4.5 meter deep is to be made. It is open from the top. Find the cost of iron sheet required at the rate of rupees 65 per meter square to make this tank. So this is also an open tank with dimensions length, breadth and height. It is given L is equal to 30 meter, breadth B is equal to 24 meter and height H is equal to 4.5 meter. So this is same. This is LH surface area and this is BH, and BH there will be two surfaces, LH two surfaces, and the bottom surface is LB. This is the bottom surface area of the bottom surface. So first we have to find out the surface area required. That means surface area of the iron sheet is equal to 2 times LH, these two surfaces, plus 2 times BH, these two surfaces, plus the bottom surface, that is equal to LB. So this is equal to 2 multiplied by L is 30 multiplied by H is 4.5 plus 2 multiplied by B is 24 multiplied by H is 4.5 plus LB, that is 30 multiplied by 24, and the unit is meter square, and this is equal to 1206. The surface area of the iron sheet required, and we have to find out the cost of iron sheet at the rate of rupees 65 per meter square. So cost of iron sheet is equal to, the cost of iron sheet is 65 per meter square and we need 1206 meter square. So 1206, this much rupees will be required, and that is equal to 8,390. Find the cost of iron sheet required at the rate of rupees 6 per meter square to make the tank. So this is all from the chapter 21B. In the next video, we'll solve the problems from 21C.